All right, this is part 2 of 2.2. We are looking at organizing quantitative data. We were in the middle of this question. We constructed a relative frequency, and we want to know, we're going to answer some of the questions that were asked here. So we've constructed a relative frequency distribution. Okay, that was right here. So 1 was 0.32, 2 was 0.22, 0.18 for 3, and so on and so forth. And so we started doing it by hand, and then we got the numbers using StatCrunch. What percentage of the time, so part B, what percentage of the time did she miss on her 4th free throw attempt? Okay, that was 7 out of 50. Okay, so that would be 7 out of 50, which is 0.14 or 14%. Okay, and you can see over here 0.14 is on our relative frequency graph at the value of 4. So then the next one, what percentage of the time did she miss the 10th free throw? Okay, so when we look at the 10th, okay, that's 1 out of 50, which is 2% or 0.02. Okay, so part C would be 1 out of 10, or excuse me, 1 out of 50, which is 0.02 or 2% of the time. Okay, part D wants to know what percentage of the time did she make at least 5 in a row. Okay, so when we think of she made at least 5 in a row, that means that the number of free throws until she had a miss would either be 6 or more. That says more, I promise. So 6 or more. So, because if her first miss came on 6, that means she made 1 through 5. If her first miss came on 7, that means she made 1 through 6, which is at least 5. And so what we're going to do is we're going to add up all the relative frequencies for 6, 7, 8, 9, and 10. So 6 is 0.06. So I'm going to take a 0.06 plus 0.02 plus 0.02 because these are both 0 right here. So I'll take a 0.06 plus 0.02 plus 0.02, which is 0.10 or 10%. So 10% of the time, she made at least 5 free throws in a row. Okay. So that's a look at breaking it down once we have a frequency, and then we created a relative frequency distribution based off of a bar graph. It's just a little bit easier that way in StatCrunch. So let's see. So the next thing we're going to talk about is when we get bigger groups or more dispersion in our groups, and we break things down into classes. So classes are categories into which we group our data. So when we've got a data set that has a large number of different discrete values, or when the set of data is a continuous set of data, so they're not easily put into single entities. So say, for example, like heights of individuals. I mean, we have fractions of heights, and so we put those into classes. So when we've got those scenarios, we create classes by using intervals of numbers. So in these intervals, we're going to have what's called a lower class limit, and that's the smallest value within the class. You're going to have an upper class limit, which is the largest value in the class, and then anything that falls in between the lower and the upper limit is going to be contained in that class. And then a class width is just the difference between consecutive lower class limits. So if we've got like a 0 to 9 and then a 10 to 19 as two classes, for example, then the class width would be the difference between 0 and 10, which is 10. So let's take a look here at this question. So we have the following data represents the magnitude of earthquakes worldwide in October 2014. So here are our classes. We have magnitude 0 to 0.9, 1 to 1.9, 2 to 2.9, and so on and so forth. And then the number, these are the number of earthquakes that fell within those ranges, within those upper and lower limits. So like, for example, a 0.5 would go in here. And then if you had a 3.2, that would go into this class. And that's how these classes are created. Okay, so in this one, part A says find the number of classes. So you just count them up. There's 1, 2, 3, 4, 5, 6, 7, 8 classes. So there are 8 classes in this one. B, what are the class limits? Okay, so the lower class limits would just be these numbers, 0, 1, 2, 3, and so on. So 0, 1, 2, 3. Okay, what are the upper class limits? Okay, that's these numbers, 0.9, 1.9, 2.9. Okay, and so on. So those would be our lower and upper class limits. And then see what is the class width. So the class width is just the difference between lower class numbers, or consecutive lower class numbers. So 1 minus 0 is 1, or 3 minus 2 is 1, but they have to be consecutive. So in this case, 1 minus 0 or 1. Okay, so you just look at the lower limits and get two that are right next to each other, find the difference, so subtract the bigger from the, or the smaller from the bigger, and that will tell you how wide each of these are. Okay, so now we want to, in this question, use the data that we had up there in problem 22. We want to know what percentage registered from 4.0 to 4.9, and what percentage registered 4.9 or less. Okay, so we've got all of this data right here, and we want to know how many of them were 4 to 4.9. So pretty sure that I pulled up this data. Yeah, here it is right here. So we've got our data. So here are our classes. Here are our frequencies. So what I'm going to do is I'm going to create a bar plot. And since I've got frequencies, I'm going to do it with a summary because this summarizes our data. So the categories are this variable 1, which was the magnitude, and then the counts came in the frequency, which is variable 2 here. But instead of looking at the frequencies, I want those relative frequencies. And I'm going to say, give me the value above the bar, and then I need to spread this out. Okay. So now that I've got it spread out, you can notice from 4 to 4.9, okay, that is going to be 11%. Okay, so that's how many fell in that category there. Oh, I guess I kind of jumped the gun. We wanted to create a relative frequency distribution, frequency histogram, relative frequency histogram. So I kind of jumped the gun on those ones. But here's how here would be our relative frequency. And to make it a histogram, if you were drawing this, you would just push these right up against each other. So I'm not going to take the time to do that. And then for our frequency histogram, you kind of get the same concept here. Okay, but again, just remember these would be bumping right up against one another. So you can see most of these occur in the 0 to 2 range, most earthquakes, which is, should be expected because we usually don't hear about earthquakes until they get into these larger ranges, which are not nearly as many as in the lower. Okay, but I'm going to bring back up this relative frequency distribution so that we can answer these questions that we had. So we did part A, part B, part C. and then so from 4.0 to 4.9, okay, that was 11% or 0.11. Okay, and then what percentage of the earthquakes registered 4.9 or less? Okay, so I'm going to look at my relative frequency, and 4.9 or less is going to be, you're going to add up 0.11 plus 0.03 plus 0.131. So you're going to add all of these up, add all of these relative frequencies together. And when I add up those relative frequencies, so I'll get 4.9 or less. When I added up all of those numbers, I got 0.986, which is 98.6%. Okay, so the vast majority of the earthquakes registered 4.9 or less. Okay, which again shouldn't be surprising because there are thousands of earthquakes. And we only hear about a handful if you see them in the news or you see or the local. Well, anything between 0 and 2 you may not even notice. So, okay. So now this next one we're going to be looking at wait times. And we've got the data right here is the number of customers waiting for a table at 6 p.m. for 40 consecutive Saturdays at Bobak's restaurant. Okay, so one Saturday there's 11 people waiting, then another there's 4 people, then 13, then 10, and so on. So each Saturday they're just gathering the data for how many people are waiting at 6 o'clock. Okay, so first question is, are these data is this discrete or is it continuous? Okay, now if we're counting the number of people, we can't have fractions of people. So this is going to be discrete. Okay, so the number of customers is going to be a discrete number of customers. Okay, then we want to create a frequency distribution of the data and a relative frequency. I've got it over here on the right hand side. Just a reminder how you do that in StatCrunch. So here are all of our data points. When you have the raw data like this, you're going to go to Stat, Table, and Frequency. And then I'm going to grab the wait time column, and I've got these two highlighted. So here are those numbers again that I had for us right here. Okay, so these ones are going to be found in or put together in StatCrunch for us. Okay, D, what percentage of the Saturdays had 10 or more customers waiting for a table at 6 p.m. Okay, so 10 or more. Okay, so 10 occurred 0.1, 11, 0.1, then 0.05, and then 0.025. So we're going to add all of those up. So you'll be 0.1 plus 0.1 plus 0.05, then plus 0.025. So when I add all of those up, okay, that's going to be 0.275. Another way I could have done it is I could have said, well, 4 plus 4 is 8, 9, 10, 11. This is 11 out of 40 nights, and that is also 0.275. So again, both are correct ways to get the relative frequency or the percentage. Oh, and that would be 27.5%. Okay, so part E, what percentage of Saturdays had 5 or fewer customers waiting? Okay, so if we had 5 or fewer, so that's going to be here. So there's 3, 6, 7, 8. So that'd be 8 out of 40, which is 1/5 or 0.2. So 20% of the nights had that many people waiting, 5 or fewer. So we'll continue in the next video as I've run out of time, but I appreciate your time in this one.